Is your data. When you're not really asking for output, you're just saying I need to make some changes to my data. Goes before the proc sort.
Thus far, you've taken the first steps in a larger picture of statistical inquiry. You've identified a data set and then used exploratory data analysis to organize and summarize the raw data in a meaningful and informative way. The tools of exploratory data analysis, including examination of frequency distributions, graphical representations of your variables of interest, and calculations of center and spread, help us to discover important features and patterns in the data, and any striking deviations from those patterns.
This all falls under the rubric of descriptive statistics. Put simply, descriptive statistics aims to quantitatively describe or summarize a sample of data.
Now you will be introduced to inferential statistics, which is our ultimate goal.
Inferential statistics allow us to directly test our hypothesis by evaluating, based on a sample, our research question, with the goal of generalizing the results to the larger population from which the sample was drawn. Hypothesis testing is one of the most important inferential tools in the application of statistics to real-life problems. It's used when we need to make decisions concerning populations on the basis of only a sample.
Inferential statistics allow us to directly test our hypotheses by evaluating our research question based on a sample with the goal of generalizing the results to the larger population from which the sample was drawn. Statistical hypothesis testing is defined as assessing evidence provided by the data in favor of or against each hypothesis about the population.
In order to really understand how inference works, though, we first need to talk about probability, because it's the underlying foundation of all statistical methods.
Here's the basic idea. As you know, statistics uses a sample to learn about the larger population from which the sample has been drawn. Ideally, the sample should be random so that it might better represent the entire population. It's very important to acknowledge, though, that this does not mean all random samples are ideal. Random samples are still random, and therefore no random sample will be exactly the same as any other.
One random sample may be a fairly accurate representation of the larger population, while another random sample might not be accurate, purely due to chance. Unfortunately, when looking at a particular random sample, which is what happens in statistics, we will never know how much that particular random sample differs from the population. This uncertainty is where probability comes into the picture. We use probability to quantify how much we expect random samples to vary. This gives us a way to draw conclusions about the population in the face of the uncertainty that is generated by the use of a random sample.